Hi, I'm Miguel Ángel Rodríguez, and in this video we're going to learn how to do FaceLandmark detection through a video recorded in a Raspberry Pi, and then we are going to use ROS Development Studio to do all the hard work, all the tests and everything, all the detection and viewing the data and the detections in RVIZ. So let's get started. First thing is we're going to use ROS Development Studio for this. If you don't know about it, just go to this website and sign up. And when you sign in, you'll get something similar to this. I've just launched a simulation that we launched in the previous video. So if you haven't seen it, go to the video that will appear in somewhere around the screen. And basically what I've done is launched a ROS core, that's it. And then what I've done is I've SSH'd to Raspberry Pi. If you don't know how to do it, go to the previous video to know how to do it. Here we have launched all the VPN connection. Then here we have SSH'd also, and we have configured it so we can see all the ROS topics in ROS Development Studio. Okay. Then now we're going to launch the camera. So we go here and we launch the recording. Well, we first launched the camera. All this was explained in previous videos and in the blog post. There's a link down below. Then we start the recording, so the service to start the camera. Okay, there we have it. Now we go to ROS Development Studio and we open a new shell. Okay. Let me test ROS topic list. Yeah, there we have it. So we have the camera image raw. We can do a ROS run RQT GUI to check that everything's there more or less. Let me open graphical tools. There we go. Transition, image view. There we go. So we have this working. So now we are going to, what do we need this for? Well, we need to do FaceLandmark detection. We need to have some kind of recorded data so that we can test again and again, and I don't have to pose in front of the camera all the time. So we have two ways of doing this. One is recording directly inside Raspberry Pi, ROSbag, or record it through this OpenVPN and store the data in ROS Development Studio. So we are going to do the second option. So let's go. So to do this, let me see my notes. Okay, so we're going to record. Let me close this. and I'm going to do ROS face landmarks, which is a package that we'll talk about, but for the moment I'm going to do here test bag, oops, sorry, test bag, okay, and then ROSbag record -a, and we're going to record the image data. Yeah, so let's have a look. So as you can see, it's recording image, ROS out, ROS by cam, and some parameter descriptions. Okay, so now I'm going to record. There we go. So I've recorded, and we're going to see what did it record. So for that, we have to go here and see this play again. Okay, so let me see if it recorded something. Yeah, as you can see, ROSbags are quite big, but one of the problems of recording ROSbags is that you need some amount of memory, and Raspberry Pi, sorry, in that case sometimes gives a lot of problems, and it tends to give problems recording long clips. So in this case, it's better to do it in ROS Development Studio because you have all the power and all the RAM and memory that you need. So let's have a look. Yeah, so ROSbag, first we're going to rename this to FaceLandmarks bag, and then we're going to copy this -L FaceLandmarks. Okay, now we are replaying the data. So now let me open another terminal so that we can launch ROS run RQT image view directly. Sorry, there we go. Okay, so what are we seeing? Well, in this case, it's an error. So the problem is that here I'm still recording, I'm still publishing. So what we are seeing here is the combination of both images. So let me stop this. Stop capture. There we go. Okay, so now that's the recording. As you can see, it's not live. I'm speaking, and this is what the images were recorded. I'm just testing different positions for the tracking system. Yeah, and that's quite it. So now we have a clip of a ROSbag, and we can play it again and again and again to do our tests. So this is the first part, how to record a ROSbag in a different computer that it's not Raspberry Pi, because Raspberry Pi normally has memory issues that make it impossible to record long clips. Okay, so once this is understood, let's go to the next part, which is FaceLandmarks. So for this, I've used some algorithms and some code that other people have made. So I won't explain in details unless it's important to talk about all that is related to ROS. I leave the links of the source code, so please check it out because it's from amazing guys that have done a lot of work for getting this done. So please check it out, and let's get started. So the next thing is, okay, so what do we have? So the first thing is see the files. So we open the IDE and we have the following. So this package I've created from scratch, but what I've used is some code for the face landmarks detection. So let's have a look. We're going to launch it and see how it goes. So we're going to use this ROS face landmark detector, which is the most basic one. So let's have a look. We are going to play landmarks that we just recorded, and then we're going to face scripts, and we are going to launch this. Okay, so it's started. Let me have a look. There we go. So this is basically what we want to achieve. As you can see here, it's detecting, it's processing the images that we recorded, and it's getting the data, basically the markers, the landmarks. As you can see, it's more or less getting the points right. It's not perfect, but we have the work done. So it works pretty well. So as you can see, it tracks no matter how you move your face and your mouth, your eyes. It tracks also the eyebrows. Very nice. And it's using the D library, and let's talk about this. So now that we've seen this ROS landmark detection, let's stop this. Okay, I'm moving this just to be comfortable. Okay, so what we are using basically is DLip, which makes all the hard work. And also we are using imutils, which it's a library made by one of the guys that I've posted the link below, which makes things much easier and nicer. So, but we're going to talk about ROS. We're going to talk about what you need to adapt those algorithms, that code to ROS. So let's have a look. So the first thing is, okay, we launch this main, which is initializing a node, and we are putting the name of the camera. So depending on the name of the camera that you recorded from, or you are recording, or you are streaming from to ROS, it doesn't matter, because RosBags, what they are doing is publishing in the ROS topics. So it doesn't matter if it's a RosBag, so if it's a recording or it's live. So basically you put the name of the image topic, and you create this face landmark detector object, which we're talking about now, with the camera topic. And that's it. So let's have a look to this class. I've made this FaceLandmark detector, which initializes like some stuff for ROS, which is ROSbag, getting where is the package where we have this code, which is in FaceLandmark's package. We initialize then some stuff, which is one of the things that it's really important, because this part, which is DLip, basically this DLip get from the face detector and shape predictor, it's the thing that costs more time. It's more time consuming, so it's very important that you do it in initialization. Once you have it, then you can iterate much faster. If you do it in the main loop, it will go really, really slow. So bear this in mind. This is really important. So we're getting the frontal face detector and the predictor. Okay, and then we just put, because depending on how your computer goes, you want to process just half of the frames. Then we go to this, so you have this camera callback, and this camera callback, each time we get an image frame, it calls this recognize, which is the one that makes all the hard work. So what do? This is ROS specific. We get the data, which is basically the image data from this topic, here from the camera topic, and we convert it into OpenCV format, which is it's BGR and so on, so it's totally different from the standard way of doing it in ROS. And we are using bridge object. We have a tutorial, a course about that in RobotIgniteAcademy. I leave a link to a video talking about this. But basically, we need a bridge between ROS images, which use the RGB standards, and OpenCV, which uses the BGR standards. Okay. Once we have the video capture, so our frame, what we do is we resize it with this image utils, which we have in scripts, image utils. So check that, the source below. That mainly what it does is resize it, yeah, so that it's easier to process and works basically. Because if you don't use this, if you don't resize it correctly, this doesn't work. So DLip is very picky about the sizes of the images and the size and shape. Okay, so bear that in mind. So once we have it, we do it in gray because we don't need colors for anything, and gray goes much faster. And then what we do is we do the detection. So we detect the face. So we can do multiple faces, but in this case, just that. And then we do the predictor. So here we do, if we want to process the frame, so normally we would do process one frame and then another, but because we are in ROS Development Studio, we have power enough to do it all the time. Just that. Then we enter into the loop, which is quite basic actually, because all this we are not doing it, because this is for just examples of the source code. Basically what we do is we get the shapes from that image, and then we visualize facial landmarks, which is with the shapes, so all the tiny details of each of the elements of the mouth, of the eyebrows and so on. We generate that image that we saw with colors, and then we post it and we paint it, and we wait for 1 millisecond, and then we cancel the image and do it again, and that's it. So this is the process of how to do this landmarks. This is the second element that we had to learn, so fantastic, but we want more. So once we have this, we have to do something useful with it. So what we're going to do is publish. We're going to do two things. One, we are going to publish all those landmarks in ROS so that we can use other programs of ROS to process that data and move the face around, the three-dimensional shape that we saw in the previous video, or do other stuff with that data. So ROSify this program. That's one. So the other is getting the orientation of the face based only in image and this facial landmarks. That is explained also in much more detail that I could do it in the link below, so please check it out. So we're going to do those two things. For that, I've created these. So one is, basically I've done this one, ROS Face Landmark Detector Publisher. So in this one, I'm using more or less what we used before, but we're doing some very important stuff. So first thing is we are creating this, let me check, this FaceLandmark Dictionary, which will save all the positions of the markers, and we'll be able to then publish it and see it in RVIZ. We'll see a demo in a moment. Then we create this calculate head pose, which is a class that I've created for this, for the orientation of the head based on those critical markers. And then we have some functions that process that critical markers, so that we don't work with all the markers, but just the very basic ones that we need to get the head position right. Those are the nose tip, the chin, the left eye corner, the right eye corner, the left mouth corner, and the right mouth corner. With those points, we can calculate the head, more or less the position of your head. If you have very good information about your camera, it will work better. In this case, we are just inferring it and calculating like a more or less, and it works more or less. So now what we're going to see is a tiny demo of it. So in this case, I'm going to use another ROSbag that I did, just because the number of points detected could vary. So in this case, I'm going to launch this guy here. So let's launch this guy, and then we're going to okay. So now, as you can see, this is more or less, it's a shorter video that I did. Basically it's the same thing. So as you can see, now we detect, we are filtering, and we're just tracking, let's say, these points. So the eyes, the nose, the mouth, and the chin. And based on that, you see that there's a blue line here, which is indicating the more or less the position of our head. But there's more. With this, let me launch this guy here. So with this, we are publishing much more. So we are publishing all the markers, not just the basic ones that you're seeing here, but all of them that generate these shapes. ROS topic list. ROS topic list. As you can see, we are publishing face landmarks array and head pose. So let's have a look. ROS topic echo minus n1 and face landmarks array, because it's really big, and we're publishing the position of each of the markers, and also we are publishing ROS topic echo minus n1 the head pose. Okay, so this is quite difficult to visualize, so we're going to ROS ROS run RVIZ, and see what we can see. So obviously this couldn't be done in Raspberry Pi. So it's really important and useful to have ROS Development Studio with an OpenVPN to Raspberry Pi, because these images that we're seeing, the images that we're seeing here could be from a stream. It doesn't matter really. Let me just layer always on top. Yep, very good. So now we are going to open, let me just, there we go. So user, simulation, source, magic face, RVIZ, and discard. There we go. So let me just put it around here. So what we're seeing here are the marker array published of each of the points detected in real time, let's say. Cool, huh? And also, now we are going to talk about this, but you can see that we have differentiation between each of the eyes, the nose, the mouth, and the chin. So we have all the data in a ROS topic, which is fantastic because we can use this for deep learning and other stuff amazing that we can do with ROS. And remember, this, we are doing it through a RosBag, but it could be done through OpenVPN with Raspberry Pi in real time. And for ROS, it doesn't matter. You just change it and put it. That's it. So good for us. And also, we could maybe execute some part of it inside Raspberry Pi. So let's talk about the code a bit, if you want. Okay. So just a few points. So we're going to talk about how we are publishing that data. So if we go to our recognize, which we talked about earlier, and we see that inside this shape, which is accessing each of the points detected for each of the parts of the face, which is like mouth, eye, left eye, right eye, and chin and nose, and I think eyebrows, left and right. That's the name. So if you see here, Landmark's dictionary, landmark name, we are doing the name by the name, which is mouth or chin, whatever, and the point index. So the mouth has like 16 points, I think. If you can see them, it's like 16 points more or less. So what we're doing is giving it a unique name for each of the points, and then we store the X and Y value, which would be the X and Y value of this image. So for example, this point number 6 would be in X 0. Blah 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 and Y 0.7 blah blah blah. Yeah. Okay. And we're storing all this in this FaceLand Dictionary, and after that we are seeing if those points are the significant, which are the ones used for painting this, for getting that where the nose is pointing. So here we do that, and we update significant point coordinates, which is around here. You see, it's another class that we've made for this. So basically here we update all the points and we update the points for significant. And then after doing this and doing it for all the points, we publish the landmarks, which we give it the whole dictionary, and we are going to talk about how this is done. And after we give the significant points with a true or false if we want it to publish or not, just to avoid overhead, and we calculate it. So calculate head pose object is another object that we've made, which is around here, which is calculate head pose. So we are going to talk about this a bit also. So let's talk about how this is published. So all the markers, so these markers, how they are published. So let's go to, I think I call it bounding box array, yeah. So I've created this class, which basically what it does is we publish in this FaceLandmarks array of type bounding box array, which is a GSK recognition message type. If you don't know what it is and how to use them, please, I highly recommend you to do, let me just, this one in RobotIgnite, talking about RVIZ markers, because we talk about a lot of markers and you'll understand much better how this is used. So continuing, we put some variables, nothing important. Well, this is important because what we do here is it's a correcting factor, because we get the data of the positions of the points, we get them in pixels, and we want it like in meters. So we make a very simple transformation so that they appear in RVIZ correctly. We have here the published landmarks, which does all the work. And essentially what it does is create this bounding box array and fill it with the data, so the time of the header and so on. Then we get the data from the nose, from the tip of the nose, which is this one here. And as you can see in RVIZ, this point doesn't move. This is because we consider it as the reference point, and based on that we position the other points. So we get that value, and then we will remove that value from each of the values of each point, so that they are referred to the same point, to the nose. Then we go through the landmarks that we sent, and we just get the position in X, in Y, which is in Z, in this case, in RVIZ. Otherwise we would see it in the plane, like in the floor, and we don't want that, so we change it from Y to Z. And then we define some dimensions of the boxes that we are coloring here, that they are around 0.05 if I remember correctly. Yeah, so 0.05 in this case. And then we do this part, which is quite nice, because this is the part that allows us to have different colors. So you see the different colors of the different elements. For that, what we do is we get the name and we change it to a number. So if it's mouth, it's 100, right eye, 200, so on. And then we add it to the face part index. So each of the points has an index, so we add it all up, and we have a unique number for each of the points. Yeah, and once we have it, we're good to go. So we add them all up, and then we publish. Simply we publish. And we get this. That's how we publish and get the markers. Let me show you, because maybe this is interesting. So it's a bounding box, and we just select the array, and we can change the coloring, in this case, it's by value, but we could do it by label or by just, so if we go here, flat color, so just a color, that's it, or label, which in this case, it gets the same, and then by value, which is the one that works, and that's it. We can put also the coordinates and so on. It's nothing important there. And finally, we are going to talk about how we are publishing the header. So where the head is pointing. So head pose estimation, we create this publisher type twist. We could do a custom message, but twist has linear and angular, which is what we need. And essentially what we do, I won't talk about this code because, as I said, there's a link in the description below that explains it much better than I could do it. And what we do is we publish. We get the transition vector item 0, 1, 2, and 3. Well, 0, 1, and 2, which are what we need. And these values are the ones that are generated here in the solve PNP, which get basically this blue line, would generate this blue line of where it is, okay? And we'll use these values in the next video probably to move the three-dimensional face that you saw in the previous video, okay? So I think that's it. So thank you very much. Please leave a thumbs up if you like the video and subscribe for more content. And please check out RobotIgniteAcademy if you need more knowledge or you didn't understand some parts that I suppose you knew. So it's a fantastic webpage to know more about ROS and be proficient with it. And also if you want to do tests and do other stuff, go to ROS Development Studio and you'll be able to do this and much more, like deep learning. We have TensorBoard and we have loads of simulations that you can use. So I think that's quite it. Thank you very much and see you in the next video. Bye.